Wow.
That was hilarious. Oh my God.
Shut up.
Okay. Here we go. Okay, so if you were gone on Friday, we are applying the first derivative test to particle motion. So your original f of x is going to be position. This is like a 10-second recap. Your velocity is going to be f prime of x. So it's the derivative. Okay, then also remember that velocity positive means moving positive direction. And then remember that when velocity is negative, that means your thing is moving in the negative direction. Okay, so if your original function is position, the derivative of that is velocity. Velocity tells you if you're going left or right, or if you're on the y-axis, up or down. Okay? So just kind of quick recap on this problem. We have a particle. It is traveling along the y-axis because it tells us that at the beginning. Then we are looking at the interval from 0 to 6. We had the equation. We took the derivative. What's the derivative called? Velocity. Then we did a first derivative test, and that told us whenever we had positive velocities, my particle was traveling up. Whenever we had negative velocities, like from 1 to 3, my particle was traveling down. Okay, then we did a candidates chart to find the absolute min and max. Also remember, when you're doing a candidates chart, you're always plugging into which equation, the derivative or the original? The original. So we plugged into x of t, which is position. Okay, so if you want to make a note of that, that's kind of a recap of what we did on Friday, and then we stopped at letter G. Okay, so letter G is new, so even if you were here on Friday, you didn't learn this yet. It says, to determine whether an object is traveling towards or away from the origin, consider the object's position and velocity. You must know both. So, if I want to know if it's going towards or away from the origin at 0, I need to find the position at 0 and the velocity at 0. Now, when I find position at 0, I'm taking 0, I'm plugging it back into position. Okay, or I can just look at the chart that I conveniently already made. At 0, what's the position? 3. So I'm just stealing that from my table right here. Okay, for velocity at 0, I'm going to plug that into velocity, which is right here. So I'd have 3 times 0 squared minus 12 times 0 plus 9. What do I get? 9. Very good. So what I want you to do is we're going to draw this scenario on a number line. So draw a y-axis. This is the y-axis. Okay, let's say that here is 0. Now remember, we said all of your motion is going to be one-dimensional. That means there's no x-axis. There's only a y-axis. Okay, what is my initial position, x of 0? 3. Now, if I got a positive 3, where am I starting? Above 3 or below 3? I said that weird. 3 above 0 or 3 below 0? Above. So 1, 2, 3. There's my particle. Okay, now, what's its velocity? 9 meters per second. Is it a positive 9 per second or a negative 9? Positive. Then if this is positive, which direction is it traveling? Up. So it's going up. So if I'm already above the x-axis and I'm traveling up, would I say I'm traveling towards or away from the origin? Away. Very good. So we're going to write that out. I kind of took up a bunch of space over here, so I'm going to have to write little. Okay, but you would put, I am at t equals 0. Particle is above the origin. And traveling up. Therefore, it is going away. Away from the origin. Okay, but if they asked you to explain, you'd have to put both of those pieces in there. I can't just know what side it's on, I have to also know which direction it's headed. Okay, now look at the next question. We're going to do the exact same thing, but at a different time. So for the next one, I want to know the time at what value? 2. I'm going to plug that into 2 places, position and velocity. Now, just to be lazy, I'm going to use the calculator for position. Okay, but it was y equals x up to the 3 minus 6x squared plus 9x plus 3. Second table, we're looking at 2. That's not right, is it? Dang. Thanks. 6. Okay, now hopefully that's right. Good, okay. So now is that right? No, it's still wrong. What did I type in wrong? x3 minus 6x squared plus 9x plus 3. Did I type that in right?
No.
Oh, it's because I didn't start it at 0. I'm stupid. Okay, alright, it's fine. So at 2, what's the position? 5. Okay, so I'm going to put x of 2 is 5.
Can you move the camera?
Yes, I can. X of 2 is 5. What else do I need besides position? The velocity at 2. So v of 2. And then I'm plugging into this guy. So it'd be 3 times 2 squared minus 12 times 2 plus 9. Okay, well 2 squared is 4 times 3 is 12. Minus 2 times 12 is 24. Plus 9. Negative 3. That's the velocity. Okay, draw your y-axis. There's the origin. Okay, what is my position? 5, which is directional. So if it's a positive 5, that means I'm up here. Right there. And then what was my velocity? Negative 3, which means my particle is going 3 whatever per second. Which direction? Down. And so if he's starting at 5, but he's pointed down, is he going towards or away? Towards. So you would say at t equals 2, particle is above the origin and traveling down. Therefore, he is headed towards the origin. Okay? Because he's already above, but then he's pointed down. That means he's going towards it in that instant. But obviously that's going to change based on what direction he's going and what position he's at. Okay? Alright, last sort of new thing, and then we're going to work another question all the way through. So remember, velocity is the derivative of position. So remember that means that velocity is the slope of position. Remember, there are 2 types of slope. You have a tangent slope, and then you have an average slope. Remember, average slope is AROC, which is f of b minus f of a over b minus a, if you don't remember that already. Okay, average slope or average rate of change, remember rate of change and slope are the same, okay, are both types of slope. If you are finding the velocity at 1x value, you are going to plug t equals 4 into velocity. Okay, that is a tangent slope because you are passing through one single point. So if I was doing velocity of 4, I would do v of 4 equals 3 times 4 squared, 12 times 4, plus 9, dot, 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 etc. Okay, you should know how to do that. That tells me the exact slope at 4. But if you want an average velocity, you would be doing this guy. Now, how many x values do you need to do an average rate of change? 2. You need an interval. So if I'm going from 0 to 2, I would do x of 2 minus x of 0 over 2 minus 0. But notice that you need an interval to find an average. So that's an important difference, is that I'm either finding the velocity at that moment or I'm finding an average velocity over an interval. Okay, then x of 2, we found it earlier. What was x of 2? 5. Minus, what was x of 0? We found it in our chart. X of 0 is 3. Divided by 2 minus 1. 5 minus 3 is 2 divided by 2, which means that it's 1. Now, let's talk about units. If my original thing, let me come up here to the problem. I'll come back down to this in a second. If it was in centimeters and time was measured in seconds, what would velocity be measured in? Centimeters per second, right? Okay. Now, for this one over here, my answer would also be in centimeters per second. Now, for my physics-y people, centimeters per second squared, what is that a measurement of? Starts with an A. Acceleration. So velocity would be centimeters per second, or if like in a car, it'd be miles per hour. Okay, but then when you do miles per hour squared, that turns into acceleration. When you do centimeters per second squared, that's acceleration. All right, turn the page. All right, we're going to do this one all the way through.
Can I use the restroom?
Sure. Okay, we have a squirrel traveling along a power line. Okay, its position in feet is a function of time measured in seconds. Okay, then look, it's cubic. How many times do we expect this squirrel to change direction? Twice. Remember, if it's a cubed, it's going to change direction twice. What if it was quadratic? It would change direction once. Remember, you always count down. What if it was a fourth power? It would change 3 times. Okay, so it says, find the velocity. How do you find velocity? Derivative of position. Okay, we should know that from Friday. So velocity equals, I got to take the derivative of this guy. What do I get? 3t squared minus plus nothing. Okay, so now also notice it says at any time t. That means leave it as an equation. So check, we're done. Okay, part B. I want to know when the squirrel changes direction. What tells me the direction of the squirrel? It's velocity, right? So if I want him to change direction, I need velocity to change signs. But in order for the direction to change, it needs to be at rest. So what do I do with my velocity equation, just like in a first derivative test? Equal to 0. What can I take out of both? What's left over? T minus 4. Which means that my critical numbers, or my at rest, are t equals 0 and 4. Set up a number line. Now, question, does the squirrel count as changing direction if it goes like plus plus? No. He has to actually change sign. So we need to do a number line. So 0 and 4. Now, the question that we just did said I'm only using my model from 0 to 6. Does this question say that? No, so that's why I'm having it go till infinity. They didn't give me a stopping point. No official interval given. Okay, but remember that we said whenever you're doing position, velocity, and acceleration, you assume you start at 0. So 0 is a starting point. They don't have to tell you that. You should know that. Okay, so from here, number bigger than 4, maybe I pick 5. 5 minus 4 is positive. 3 times 5 is positive. Both positive means positive. 0 and 4, what can I pick between those? 2. 3 times 2 is positive, but 2 minus 4 is negative. Do I check on the other side of 0? No. So these are the signs for velocity. What does that tell me about position? Okay, he went down, then up. Okay, now question. Did he change direction at 4? Yes. Did he change direction at 0? No. Why doesn't 0 count? Because that's the beginning. You can't change direction at the beginning. That's the starting point. So I would say he changed direction at t equals 4 because v of t changes sign. Okay, but remember that if it didn't change sign at 0, he still was at rest, but it doesn't count as a sign change because it's the beginning of the interval. Okay? Alright, next one. When is the squirrel traveling to the right? When is he traveling to the left? So he's on a power line. He will be going to the right when velocity is what? When v of t is what? Positive or negative? Positive. So where was v of t positive? What interval? 4 to infinity. When would my squirrel be traveling to the left? 0 to 4. Because v of t is negative or less than 0. Okay? Alright, now, we briefly talked about this on Friday, but in case you forgot. Okay, it says, when is the squirrel farthest to the left in the first 5 seconds? Farthest to the left, would that be a maximum or a minimum position? Farthest to the left. That is asking you for an absolute minimum. Now, remember that we said, if it's an absolute, they needed to give you endpoints. They didn't give me endpoints like they usually do, but they still told me in the first 5 seconds. What interval is that? 0 to 5. Okay, so the first 5 seconds tells me 0 to 5. So, set up a chart. What is going to go in my chart for the first 5 seconds? 0. 4 is a critical number, and then 5. Very good. Okay, then in my calculator, I'm going to type it in. So it's x up to the 3 minus 6x squared, and then plus 1. Second chart. Okay, at 0, my squirrel was at a position of 1. At 4, he was at a position of negative 31. And then at 5, he was at a position of negative 24. Okay, notice that I am plugging into the original x of t. Okay, you are not plugging into the derivative when you're doing a chart. Okay, from there, what is his minimum position? Okay, so I'm going to put min position is negative 31 at what second? T equals 4 seconds. Okay, now look at the next one. I want to know when he's farthest to the right. Well, when was he farthest to the right? At the beginning. Okay, so I'd say max position is 1. It occurs at t equals 0 seconds. Okay, and then remember, as long as you correctly label your graph, you don't have to put a big, long explanation after that. Okay? Alright, next question, letter G. At 5 seconds, is the squirrel moving towards or away from the origin? What 2 ingredients do you need to answer that question? At 5, we need the position and the velocity. So, towards or away, put here, you need position and velocity. And you have to have both to be able to answer the question. Just knowing one or the other is not going to work. So let's find the position at 5 first. Do I need to plug it in by hand or is it already in my chart? Already in my chart. What was my position at 5? Negative 24. That tells me where my squirrel starts. What else do I need? My velocity at 5. And I'm going to plug in, if you look right here, I have my equation. It's 3t squared minus 12t. So it's 3/5 squared minus 12 times 5. Okay, 5 squared is what? 25 times 3 is, and then 12 times 5 is 60. What is 75 take away 60? 15. Okay, so draw your number line. He's running along a left-right axis. Here's the origin, 0. Where does he start? What position? Negative 24. Okay, there's your little squirrel. And then which direction is he running if his velocity is 15? To the right. And so if your squirrel is on the left side but traveling to the right, which direction is he going, towards or away? Towards. So I would say at t equals 5, squirrel is on left side of origin and traveling right. Therefore, towards, bless you. Okay? Okay, now do the same for 6. What 2 ingredients do we need for towards or away? Position at 6 and velocity at 6. I'll put my chart back up here. Remember, this is the position graph. If I'm at 6, the position is 1. Velocity at 6, I'm plugging into 3t squared minus 12t. So it's 3/6 squared minus 12 times 6. So let's type that in. 3 times 36 minus 12 times 6. Okay, comes out to be 36. So draw your number line. Where's your squirrel going to start? What position? Okay, so here's the origin. My squirrel's at 1, which is on the right side. And then which way is he traveling if his velocity is positive? So your little guy. Okay, there he is. No, those are his hands to hold the acorn. Oh my God.
Oh, that's a good acorn.
Thank you. Do they have ears? Like little ones?
Yeah, they like it.
And then little eyes. Look at him.
That does not look right.
Pitter patter, pitter patter. Where is he running?
Away from the orange.
Away.
And I'm running away from the squirrel.
Okay, listen, haters. Draw a better squirrel and then talk to me. It's in his hands. Those are his little hands.
What is he, a squirrel hybrid?
A squirrel bird hybrid. Okay, one of y'all come and draw a better squirrel. Then. Do it. Therefore, away. That will be on your next quiz. Draw a squirrel. That is better than mine or you fail.
Every test, he would have the back blank, and so you could draw whatever, and if you liked it, he gave you extra credit.
What?
Yeah.
Ridiculous.
No! I thrived in that crap class. Extra credit, man. The extra credit was so easy.
Wow.
Like, let's say someone made a pen in the trash can, 10 points extra credit.
What?
Yeah.
What a circus. Okay, last one. I want average velocity, 0 to 5. Do I plug in 0 or 5 to velocity? No, that's an average rate of change. Okay, and also notice they didn't give me just one value, they gave me two. That's an interval. So, yep, you do x of 5 minus x of 0 over 5 minus 0. Now, something that's very important. When I do the average rate of change, remember it's f of b, f of a over b minus a. These should be position in your formula. So not f prime of b and f prime of a, that's wrong. So make sure these are positions. What was the position of 5? Look at your chart.
Negative 24.
Negative 24. What was the position at 0? 1 over 5 minus 0 is 5. So I'd get negative 25 on top, divided by 5 on bottom, which is negative 5. Then it says here, indicate units of measure. So look back up. What was our distance measured in? Feet, bless you. And our time was measured in seconds. Can you imagine a squirrel going 15 feet per second?
Oh my God, that's a big one.
I'd be running away from that squirrel too, honestly. Okay, the last page.
Why am I Achilles?
Nope.
They want my appendix. I don't need that.
What? Oh. Okay, last little thing. We have to do a graph. Okay, so we're going to skip the next problem. It's very similar. You can do it for funsies if you want. Okay, so let's just real quick. We are going to talk about graphs of what?
I didn't sleep this time.
Alex, give him a gentle poke.
What, can I come with you?
No.
You had any cookies?
Ebenezer. Are you okay? Good morning, sunshine.
Today's my turn.
I'm so weak.
Okay, so look. Graphs of velocity. Okay, when will the particle be at rest? When velocity is what? Okay, focus, last thing.
0.
Look, he wakes up and knows stuff. Okay, your particle is going to be at rest when it is not moving. That means its velocity would be 0. Now, if I'm looking at a graph of velocity, where will I find the zeros?
Not the 0.
The x intercepts. So anywhere that the graph has an x-intercept, velocity is equal to 0. That means that it is at rest. Okay, when the particle is traveling up, velocity needs to be what? Positive, which means that it will be where on the graph?
Why?
Above the x-axis. If I'm looking at velocity, velocity is positive when it's above the x-axis. Okay, my particle will be traveling to the left when velocity is negative, which means that it will have to be where? Below the x-axis. Okay, then the last two things. My particle will be farthest to the right when I have a relative or absolute max. It will be farthest to the left when you have a relative or an absolute min. Now remember, it only turns into an absolute if you have endpoints. So I'm going to put here absolute when given an interval or endpoints. So if you know the time that you're looking at, you can cut your graph off and call it absolute. But if you don't know, you'd just be finding relatives. So when you're ready, turn the page. We have one more left.
One more page?
Well, just a graph. Turn the page. Are you ready? The last one.
Oh no. Wait, I gotta do something.
Here we go. Okay, ready, Ebenezer, for your pop quiz?
What?
Okay, turn the page. What is this a graph of?
Velocity timeline.
Okay, it says right here, this is a velocity graph for a particle on the y-axis. When is the particle at rest? This is velocity.
1, 5, 8.
Okay, 1, 5, 8 through 10. Notice that it stays on the x-axis that whole time. So I would say t equals 1, 5, and 8 to 10. Or if you prefer, you could have written it like this. Okay, it doesn't matter. Either one, they're the same thing. How would I describe that? How do I know it's at rest?
That's 0.
V of t equals 0. That is the definition of at rest, is that your velocity is 0. Okay, next question. When is my particle traveling up? What am I looking for on my graph? A positive velocity, which means that it needs to be above the x-axis. What intervals is it above?
0 to 1,
0 to 1,
5 to 8.
5 to 8. So 0 to 1, 5 to 8. Justify because velocity greater than 0. Okay, ready? Next question. When is the particle traveling down? What would my velocity need to be? Okay, from 1 to 5 because my velocity is what? Negative. Could you write this? Sure. Okay, if you prefer words, fine. Okay, you should be able to do it with less thans and greater thans, but if you like is negative better, that's okay. Okay, next one. Identify relative mins and maxes. Okay, what type is number 1? Is that a min or a max? How does the derivative change from positive to negative? It's a max. Very good. So I have a relative max at t equals 1 because velocity changes plus to minus. That makes it a max. What happens at 5? Relative min. At t equals 5 because velocity changes negative to positive. But notice the only difference from what we did last week to what we're doing now is instead of calling it f prime, we're calling it velocity because velocity is the derivative of position. Okay, last one. Find velocity at 0. Velocity at 0. This is a graph of velocity. So what is v of 0? 4. What does that tell me about the particle? Does it tell me where it is or which direction it's going? Velocity. What does velocity tell you? Okay, which way is it traveling? Up or down?
Down.
4 is positive. So my particle is traveling up. What else do I need to know to answer that question? Position. So I want you to go back to the question stem. It tells us the position in words. Suppose the graph below, I'm reading right here, is the graph of velocity for a particle traveling along the y-axis. At time 0, the particle is 5 centimeters above the origin. Oh, oops, I can't read. Okay, x of 0 is
X is 6, man.
6. So, come down. Let's add that to our analysis. Okay, if my position is 6, which side am I starting on? Above or below are your choices. Okay, so now draw your picture. We have a thing starting above the origin at 6. So let's say here's 0, here's 6, here's my particle. And then which way is it traveling if the velocity was positive 4? up. So is he going towards the origin or away from the origin? Therefore, away. Okay, then last thing, let me also say, if you only draw this picture without these words, you will not get the justify point. You have to put it in words. The picture can kind of help you, but it does not count as your explanation. Okay? You are going to have a quiz probably on Thursday. We have a pep rally on Friday, so the day's going to be short.
We have a quiz on Halloween.
Yep.
I asked that too.
Yay!
I'll come to school, because I'm going to be a ghost.